Hi, you're right. Welcome back to Mathematics for your next video lesson. Today we're looking at how we can use ratios to solve a variety of different problems. We're going to start off the lesson with some flashback questions from the last video. So in the last lesson we looked at an important skill which is called how to simplify ratios. If you watched and you remember, you can have a go by pausing this video and trying these four by yourself first. Okay, so for the first example, we're looking at a ratio of 10 to 100. And we're saying to ourselves that on the left-hand side, we have one lot of 10. And on the right-hand side, we have 10 lots of 10. So if we divided both these number by 10, we would end up with 1 to 10. And there is our simplified version because these numbers can't get any smaller. We want them to be as small as possible, but we want them to be whole numbers. So we couldn't do 0.5 to 5. It's got to be whole numbers. For the second one, we have 12 to 24. Now, the common factor for this one is going to be 12 because on the left-hand side, we have one lot of 12. And on the right, we have 24, which is two lots of 12. So we can simplify this ratio as 1 to 2. 1 12 to 2 12s. For question C, we're trying to think of a number that is going to multiply into 12 and into 30. So the best answer is going to be 6. So 2 works, but 6 is a better answer because it's a bigger number. So 12 is 2 lots of 6 and 30 is 5 lots of 6. So our simplified ratio is 2 to 5. If you have a calculator at home, you can check these answers by entering these as fractions. If you type into your calculator 12 over 30 and then press equals, it'll simplify to 2 over 5, and that's why 12 to 30 simplifies to 2 to 5. It's the same logic as fractions. And for question D, a common factor of 35 and 49 would be 7, because 35 is 5 lots of 7 and 49 is 7 lots of 7. So simplifying, we have 5 to 7. Once again, if you put into your calculator 35 over 49, it'll simplify it and tell you the answer is 5 over 7. So you can check your answers with a calculator if you have one handy. Okay, like I said, today's lesson is all about using ratios to solve a bunch of problems. We're going to look at 5 different examples of problems we can solve using ratios. Here is our first one. We have a cake mix requires flour and butter in a ratio of 5 to 2. So for example, if we put 5 grams of flour in, we would need to put in 2 grams of butter to keep the ratio. So if we're going to use 850 grams of flour, how much butter is going to be needed? So the 5 part, the left-hand side, is going to be 850. We're trying to figure out what the corresponding 2 part is going to be. So these are pretty big numbers. They're a bit hard to work with. We have an equivalent ratio. So we're saying to ourselves 5 to 2 as a ratio is the same thing as 850 to what? Now, we handled some of these in the last video lesson. What we're essentially trying to find here is what number 5 is being multiplied that turns it into 850. So we're trying to figure out what number the left-hand ratio is being multiplied to turn into the right-hand side. Now, I don't know about you, but if you ask me how many times does 5 go into 850, I'd say I don't know. I need to check with a calculator. So we're going to figure out what number this is by working backwards and doing a division. So 850 divided by 5 works out to be 170. This means that from the left-hand side of the equal sign to the right-hand side, the numbers are being multiplied by 170. So if that's what's happening to the 5, we need to do the same thing to the 2. We're going to do 2 lots of 170. That works out to be 340. So the missing gap here is going to be 340 grams. Okay, so 5 times 170 is 850. We figured that out by dividing. We take that same number and we multiply it to the other piece, and we get 340 as our answer. So there's our answer. If we're going to have 850 grams of flour, we need 340 grams of butter. Okay, for our next one, we have Rick and Morty. They are splitting 63 pickles in a ratio of 5 to 4. What this means is every time Rick, who's on the left, every time he gets 5 pickles, Morty is going to get 4. So if Rick got 10, Morty would get 8. But we're trying to make 2 numbers here that are going to add up to a total of 63. So how many pickles do they each receive? We can do this with a bit of trial and error, but I'll show you a way that we can solve it directly that requires no trial and error. Where we're going to start is we're going to say that if Rick is getting 5 parts every time Morty is getting 4 parts, this ratio is kind of sharing 9 parts. 5 here, and 4 here. So once we've recognized that, all we need to do is we need to split 63 into 9 equal parts. Then we can put 5 of them on the left and we can put 4 of them on the right. So to split 63 into 9 equal parts, we need to do 63 divided by 9. That works out to be 7, okay? So each of these parts is going to be worth 7 pickles, and then Rick is going to get 5 of those parts. So Rick is going to get 5 lots of 7, and Morty is going to get 4 of the parts. So he's going to get 4 lots of 7. So we do 5 times 7, and then Rick is going to get 35 pickles. And we do 4 times 7, and Morty's going to get 28. Okay, so if we added 35 and 28, we would get 63, so it works out. And now Rick has a 5-part share, and Morty only has a 4-part share. So once again, 5 parts to 4 parts is 9 parts in total. Divide 63 by 9, and you get how big each of those parts is. We do that number times by the 5 and times by the 4, and you've got your 2 pieces. Okay? Now it's a bit of a tough one at first if you haven't seen a question like this before, so we'll do another one to get a bit more practice. This one's got a triple ratio. We have Zara, Shalise, and Cleosha. They found $2,400 buried in Shalise's backyard. They decide to split it in a 1 to 3 to 2 ratio. So every $1 that Zara gets, Shalise is going to get 3 because it's her backyard, and Cleosha is going to get $2, maybe because it was her shovel, I don't know. So we need to find out how much they are each going to get. So if that last example made sense to you, you can pause and try this one by yourself, or if you're not too confident yet, you can follow along with me. So once again, we have 1 part here, 3 parts here, and 2 parts here. So in total, we are trying to split up 6 pieces. Okay, 1 to 3 to 2 is 6 parts in total to the ratio. So once again, now we've got that total number, all we need to do is figure out what we're sharing, split it up into 6 parts, so we can put 1 of them here, 3 of them here, and 2 of them here. Okay? So we'll do 2,400 divided by 6. That works out to be 400. Okay? That means Zara is going to get 1 lot of $400. Shalise is going to get 3 lots of 400, and Cleosha is going to get 2 lots of 400. So Zara is going to get 400. Shalise is going to get 3 times 400, so she's going to get 1,200 or 1,200. And Cleosha is going to get 2 lots of 400, so she gets 800. Once again, if we add 800, 1,200, and 400, we get 2,400. So we have done it correctly. So this is 2,400 split up in a 1 to 3 to 2 ratio. Okay, up next, we are starting to look at scales with regards to maps, because this is where a lot of people use scales and ratios in real life. So we have a map is designed so that 1 centimeter on the map is 20 meters in real life. Okay, so anything you measure on the map, if it was 1 centimeter, in real life, that distance would be 20 meters. Okay? Question A, what is the ratio of the scale for the map? Okay, so we've got a scale of 1 centimeter to 20 meters. Like we said, 1 centimeter on the map is 20 meters in real life. However, this is not a simplified ratio because ratios should not have units, they should just be numbers. So what we need to do is we need to convert 20 meters into centimeters to see what our ratio is. So for this, we need to know that, of course, a meter is 100 centimeters. So if we're converting from meters to centimeters, we're multiplying the number by 100. If we do 20 multiplied by 100, we get 2,000. So 1 centimeter to 20 meters is the same thing as 1 centimeter to 2,000 centimeters. Now both sides of the ratio are in the same units. We can just drop the units and say our ratio is 1 to 2,000. So whatever you measure on the map, in real life, it's going to be 2,000 times the distance. So now that we can use that, question B, 2 objects are 100 meters apart in real life. How far apart will they be on the map? Okay, well, let's think. If they were 20 meters apart in real life, that would be 1 centimeter on the map. Except instead of 20 meters, we have 100 meters. Okay, so let's think to ourselves, if we had 1 centimeter matches up with 20 meters, what's going to match up with 100 meters? Well, we can think about this as 20 meters into 100 meters. That goes 5 times, yeah? 100 meters is 5 lots of 20. So to figure out the left-hand side, the part on the map, We just need to multiply the 1 by 5 and get 5 centimeters. So if we have a ratio of 1 centimeter to 20 meters, if that was scaled up to become 100 meters, the part on the map would need to be 5 meters because this ratio is being multiplied by 5 to get this ratio. Okay, one last example for today. We have a treasure map is drawn with a scale of 1 to 10,000. So whatever you measure on the map, in real life, it's going to be 10,000 times as big. Okay, so the question is, two objects are 12 centimeters apart on the map. How far apart are they in real life? Okay, so we're using our scale of 10,000. So 1 on the map is 10,000 in real life. On the map, we are measuring 12 centimeters. So how are we going to figure out what goes for the part in real life? Well, if we're multiplying the 1 by 12, we need to be multiplying the 10,000 by 12 as well. Okay, so whatever is in the real life segment, it's going to be 10,000 times as large. So we're doing 12 multiplied by 10,000. That works out to be 120,000 centimeters, which is a very big number. And if you said to me two things were 120,000 centimeters apart, that's hard for me to visualize in my head. So let's convert that into something more useful. We could instead write that as meters by dividing by 100. Remember we said before that 1 meter is 100 centimeters. So if we're going from centimeters to meters, we need to divide by 100. 120,000 divided by 100 works out to be 1,200. So now if you said to me these two things are 1,200 meters apart, that's a bit easy for me to visualize because those are the kind of distances I'm used to. Or we could convert once more and say, well, this is the same thing as 1.2 kilometers as an alternative answer. Okay, so all three of these answers are correct. It's just that these two are a bit more realistic for large measurements. We usually only use centimeters for small measurements. Okay, that's the end of today's video. There are some more questions like this in a worksheet posted on Google Classroom. So please have a go at those examples and let me know if you need any help or you would like some more examples. Thanks for watching. I'll see you next week. Thank you. Bye.